Welcome, and we are going to continue exploring inverse functions and their properties. So we have the idea of an inverse function. We haven't found it algebraically yet, but we have the idea that, if we compose them, they kind of cancel out, they undo each other, and we get out whatever we initially put in, right? Very helpful, very, very helpful. What other properties do they have? So I'm going to tell you that f and f inverse, as I have them defined here, they are inverse functions. We're going to look at their graphs and see if we can find anything interesting. Okay, so I have their functions here. Okay, so again, the red one is the original function, and then the blue is the inverse function for that red function. And you could actually say it the other way around too. The red is the inverse of the blue, so tomato, tomato. Okay, but I'm looking at these and I'm wondering what you notice. I notice a few things. Pause the video and see if you can identify some things that are interesting in this graph. Okay, well, one thing that I notice is that they seem to be sort of mirrored. Okay, right? Like I could maybe move the blue so that it could be on top of the red function. And that's actually true. If I imagine reflecting across the line y equals x and using that as my mirror, I would get the same thing. So when I'm thinking about symmetry, there is symmetry over the line y is equal to x. Okay, so that's interesting. Okay, if we continue looking, what I notice here is that this graph, so my original function, it starts at the point 1 comma 0. This one starts at 0 comma 1. And that's actually that makes sense because if I mirror over the line y equals x, I'm interchanging the x and y values because I'm literally saying y is now x and x is now y. That's what that line mirrored means, or mirrored over that line means. Similarly, if I have the point 2, 1, right, I should find the point 1, 2 on my other function. Oh, look at that, isn't that fun? And then here I'd have, 5, 2, so then 2, 5 should be on my function, on my inverse function, right? 2, 5, it is indeed. Okay, so then if AB is a point on the original function, okay, then BA is a point on F inverse of X. Okay, so interchange the X and Y. And because of this property, we actually can talk about the domain and range. Okay, so imagine that we have, the domain and range, and we're looking and comparing these for the function and the inverse function. Okay, and I'm going to come up with some silly general things like let's pretend the domain for f is AB. I don't know what it is. Let's just call it that. And then its range is CD. And let's do parentheses bracket. I don't know, something funny. Okay, because we switch the domain, or because we switch the coordinates, right? A goes to B, B goes to A. That means we're interchanging domain and range as we go from the function to its inverse. So that means if I look at the domain for f, that should be the range. Sorry, if I'm looking at the domain for f inverse, that should be the range of f. So this should be C comma D. In the same way, if I'm looking at the range of the inverse, that should be the domain of f. So this should be A, B, okay? These things switch, okay? So sometimes, and one thing that I often do is if I know that the function's invertible, range is super hard for me to find, but I find the inverse function, right? Find its domain and then say, oh, okay, that's the range. Okay, and that's a nice little shortcut that I do. So I can, because domains are easier to find. So find the domains for each and then just use the inverse property to say, oh, okay, this is what the range must be. Okay. So keep those three properties in mind. So symmetry, the points end up switching between a function and its inverse, and then the domain and range switch as a result. Okay, so then when I'm looking at this whole thing, it says, okay, what is the function value for f of 2? Okay, so now I just need to think, well, f inverse of 2 is going to be a number. Let's call it k. But then what this means is that if I'm looking at the original function, these things switch, the inputs and outputs switch. So f of k is equal to 2. So now I'm looking through my table and saying, oh, like this is a y value, right? Y value. Okay. Now I'm looking for the value k that corresponds to a y value of 2. Y value of 2. Oh, okay. So then k must be 1. Okay. So that's kind of a neat little idea. Okay. For the second one, f of f inverse of 3. Okay. So again, f of f inverse of 3. Okay. Now, if you're clever, right, you remember, oh, like this is the cancellation property. This should just be 3. Okay. Makes total sense. Okay. But again, if you want to go through it in a little bit more detail, you might sidestep and say, okay, well, I don't know what this is, but I can come over here and say, okay, well, if I know f inverse of 3, this is equal to a number, let's call it m this time. That means that's true if f of m, is equal to 3. So what's that mean that m is? Okay, so I'm looking for an x value that has a y value of 3. Okay, that would be 2. Okay, so m is 2. Okay, and so now I'm saying this is f of 2. So I'm saying these things are all equal, and then I'm saying this is an x value, right? I'm inputting into a function, and now I can say, okay, that would indeed be 3. Okay, according to the table. So I got the same thing from cancellation laws as I did by going through a few more steps. Okay, isn't that fun? All right, last example. So it says, here's a graph of a function below. We want to sketch the inverse. Okay, to help sketch the inverse, remember there's symmetry over this line. Okay, so I'm just going to sketch that line here in green. So boom, 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 something like this. And okay, it's not exact. Again, if you wanted exact, you'd use a graphing utility. But it's good enough for now. Okay, so now I want to mirror this across this line as much as possible. I can also use the fact that this is what, 0, 2. So I'd have a point at 2, 0. Okay, so something like that. So that point goes over there. And then to mirror this thing, again, do your best. This looks like it hugs the x-axis as I go in the negative direction. So that means now I'm going to hug the y-axis as I go in the negative direction. And then I want to make sure to hit that point and then do something like this. Okay, as best as possible. Okay, so do your best to mirror these things if you're sketching a function in its inverse. And you can also make use of that point property. So again, this was 0, 2. This goes to 2, 0, interchanging those x and y coordinates.